we learn about the next law, Kirchhoff's voltage law, that is known as KVL, Kirchhoff's voltage law. The statement of Kirchhoff's voltage law, the algebraic sum of the potential differences. According to Ohm's law, V is directly proportional to I, means V is equal to I into R. R is called as resistance of the conductor. Therefore, V means potential difference, that is the product of current and resistance. Potential differences IR and electromotive forces. Electromotive forces means that EMF of cell E1 and E2. That says EMF, electromotive force E1 and E2. Electromotive forces in a closed loop is zero. The algebraic sum of the potential differences and the electromotive forces in a closed loop is zero. Therefore, the mathematical statement is summation of IR plus summation of E is equal to zero. Because of the algebraic sum of potential differences and electromotive forces is equal to 0. Therefore, summation of IR plus summation of E is equal to 0. Consider in that loop, a closed loop is considered. Closed loop means the conductors, a closed path in an electrical network is known as loop. First, in a closed loop, A, B, F, G, A. Closed loop means A पासून स्टार्ट होईल पुन्हा A पर्यंत येणार. अशा लूप म्हणायचे क्लोज लूप. A closed loop is considered as A, B, F, G, again A. In a closed loop, A, B, F, G, A. In that loop, here sign conventions are used. Current flowing in that direction. Current flowing in the direction I1 flowing through the resistor R1. I1 R1. The potential drop across each I1 R1. Current flowing in that direction. Therefore, the potential differences are taken as negative. म्हणजे करंट या डायरेक्शनने मूव्ह होत आहे म्हणून आपण काय करणार पोटेन्शियल डिफरन्स निगेटिव्ह. करंट या डायरेक्शनने मूव्ह होत आहे पुन्हा I3 करंट फ्लो होत आहे या डायरेक्शनने इज टेकन ॲज अगेन निगेटिव्ह. अगेन I1 R3 इज अगेन निगेटिव्ह बिकॉज ऑफ करंट ज्या डायरेक्शनने आपण दाखवतो आहे त्याच डायरेक्शनने काय होत आहे त्या करंटची डायरेक्शन आहे आणि त्या जंक्शनमध्ये जे क्लोज लूप आहे त्या क्लोज लूप मध्ये त्याची डायरेक्शन या डायरेक्शन मध्ये आहे. बिकॉज ऑफ द करंट फ्लोज फ्रॉम पॉझिटिव्ह टू निगेटिव्ह टर्मिनल. देयरफॉर करंट शोइंग इन दैट डायरेक्शन. देयरफॉर I1 I2 are taken as I1 I3 and I1 across the R1 R5 and R3 are taken as negative. The potential differences. Therefore, in a closed loop, minus I1 R5 minus I3 R5 minus I1 R3. The algebraic sum of currents means potential differences is V is equal to I according to Ohm's law. And summation of EMFs. Therefore, the sign convention for EMF when positive is taken as positive, negative to positive terminal, currents flowing in that direction, negative to positive terminal. Therefore, negative terminal to positive terminal, EMF is taken as positive. When EMF is taken as negative, positive to negative, suppose ही डायरेक्शन जर अशी आली असती असा फ्लो होत राहिला असता पॉझिटिव्ह टू निगेटिव्ह असता तर then it can be taken as negative. Therefore, positive to negative. Current always flowing from battery terminal of positive terminal to negative terminal. Therefore, in that direction. Where I2 flowing through R2 in that type. I2 and R2. The potential difference is taken as negative. Means minus I2 R2. Again, I3 R5 minus I3 R5 and minus I2 R4. And then again potential EMF from negative terminal to positive terminal is taken as positive plus E2 is equal to 0. Therefore, in a closed path, the algebraic sum of potential differences, that is IR, and the electromotive forces in a closed loop is 0. Therefore, if that two equations can be presented as the Kirchhoff's voltage law. Here, voltage law means the potential differences across each component plus the electromotive force, energy is conserved, and in first law, Kirchhoff's current law, where charge is conserved. In AC, charge is conservation of charge, and in the voltage law, energy conservation. Therefore, according to the Kirchhoff's voltage law, the algebraic sum of the potential differences and the electromotive forces in a closed loop is 0. Hello student, we learn about Weisstone's meter bridge or Weisstone's network. Four resistances are connected in an arm. In the rectangular frame, four resistances P, Q, R, S. P, Q, R, S are four resistances. Are connected in the four arms in the rectangular arm, and a rectangular frame is formed, and they are diagonally connected. Across the terminals B and D, galvanometer is kept fixed in between that two terminals, B terminal and D terminal. And its another diagonally opposite, the point at A and C, battery and key are connected in series combination across the Weisstone's network. Therefore, to form a Weisstone's network, a rectangular four resistances are connected in the four arms, one arm, second arm, third arm, and fourth arm. Therefore, that fourth arm, PQRS are four resistances are connected in that network. Therefore, two closed paths are formed. Two closed path means closed loop. First loop is considered as, in a closed loop, A, B, D, A, B, G, D, A, B, G, A, B, G, D, A. G is nothing but the point, but the galvanometer is fixed in that loop. Therefore, A, B, D, A. The loop is considered as A, B, D, A. In that loop, first the current are divided into, I current is divided into that two arms, I1 and I2. I is equal to I1 plus I2. Current is split in two arms, I1 and I2. resistor P as the same is along the same direction. Therefore, I1 flowing through that P is taken as negative according to the sign convention. I1 and is flows through that P. I1P is taken as negative. Then current flowing through that is I1 into G. That current is flowing through that I1 in that sense. Therefore, current flowing through that same direction. Therefore, I1 minus is taken as minus I1 into G plus current flowing through I2 but in the opposite direction. Here the sign convention, the sign of the current is flowing in that direction. Therefore, I2 and the closed loop is considered in the opposite direction. Therefore, I2 is taken as positive plus I2, yes, I2 is equal to 0. In a closed loop, current and potential differences is equal to 0. But here no battery is present in that loop, therefore no EMF is taken as. Therefore, in another loop, in a closed loop, B, C, D, A, B, B, C, D, B, B, C, D, B. Therefore, in that loop, current flowing in that direction, therefore is taken as minus I1 minus IG. करंट या डायरेक्शन आपण लूप कन्सिडर करतोय बी सी, त्याची डायरेक्शन सेम आहे. जो लूप आपण कन्सिडर करतोय त्याचप्रमाणे त्याची डायरेक्शन इन देअरफॉर इज टेकन ॲज निगेटिव्ह minus I1 minus IG where current is flowing through I1 and another branch that current is IG is equal to that current flowing through that galvanometer is IG is equal to G. IG into G. I1 into IG into G. Galvanometer current flowing through that galvanometer. I1 minus IG. I1 minus IG. Current flowing through that resistor Q. Again, here direction of I2 plus IG. I2 flowing in that direction. IG flowing in that direction, therefore current flowing to that resistance R is I2 plus IG. Therefore, I2 plus IG is taken as that loop is considered as B, C, D, B. In that manner, therefore the current flowing in opposite direction is taken as positive plus I2 plus IG into R. Current flowing in that direction minus is taken as loop is considered as here in that direction B, C, D, B. Therefore, current flowing through opposite direction is taken as positive plus IG into G is equal to 0. Where Wheatstone's network balancing condition is when the potential at point B and potential at point D are same. Means VV is equal to VD. Potential at point B is equal to potential at point D, or current flowing through the galvanometer is 0. IG is equal to 0. There is no potential difference at that point. Therefore, does not current flow through the galvanometer means IG is equal to 0. Therefore, consider the condition minus I1P, that factor is 0, plus I2S is equal to 0. Therefore, I1P is equal to I2S. From that equation number 1, and from second equation, minus I1 minus IG into Q, where IG is 0, therefore that term is 0, plus I2 plus IG into R is equal to 0. but negative positive sign Ig is equal to 0, therefore minus I1Q is equal to I2R plus I2R is equal to 0. Therefore, I1Q is equal to I2R. Transfer that sign, that minus I1Q in that side, therefore I1Q is equal to I2R, therefore I1 upon I2 is equal to I1 upon I2 is equal to R upon Q. I1 upon I2 is equal to R upon Q. From that equation, I1 upon I2 is equal to S upon P. S upon P. Therefore, from that equation, S upon P is equal to R upon Q. Means P upon S is equal to Q upon R. Means P upon, from transfer that side, therefore transfer the term P into PR is equal to SQ. PR is equal to SQ. Therefore, P upon Q is equal to S upon R. This is the balancing condition for Wheatstone's meter network. Therefore, Wheatstone's network is balanced when the galvanometer current flowing through that is 0, means Ig is equal to 0, and the four resistances are given. P upon Q is equal to S upon R. That condition is obtained. P upon Q is equal to S upon R. This is the balancing condition of Wheatstone's network.